Slideshow. Okay. Hello everyone. Nice to see you again. And it seems like a little bit rainy outside and storming, but I am very glad to see you in the campus and in the classroom. Thank you for attending. And for today's talk, we have finished our overview, finished the theoretical foundations, and we are now working more on the method of the alignment. So for today's lecture, we're going to talk about the data. So that's why today's topic is about data is gold, human in the loop, data collection, and co-annotation. And let's start here. For a quick recap, last time we had talked about the different alignment techniques that we can use for mitigating the misalignment between humans and AI. And although we covered more content here, but this is, I think, a good summary of the main content last time, including the prompt engineering, inference time interventions, supervised fine-tuning, RLHF, DPO, and multi-agent alignment method regarding different modeling effort and alignment degree. So for today's talk, we're gonna talk about three parts, and here's our outline. First of all, we will talk about why data is gold, or why data is very important here. And the second one is about representative data collection method, where we're gonna cover a lot of the most typical data collection methods, which would be used in future AI-related modeling and projects you would conduct. And the third one is about data validation and consensus building, especially given that if we would use or involve human in the loop to annotate the data, we would, of course, showing our evaluation on the iterator reliability or the consensus, so to ensure that our data quality is pretty good. And the fourth part is about the data bias in representations, where we want our data set that will be trained for the AI models to be equal and to be representative for most of the population. And by joining today's class, here's our learning goals again. First of all, learn the typical ways of collecting data sets. Regarding to the second one, learn how to validate and evaluate the agreement for the annotators, which would be helpful for your papers research project regarding the consensus building, and learn the importance and method to ensure data representations. Let's start from the first one about the why data is gold. So as we know that data's quality is the foundation of machine learning performance, and the data also have some life cycle, starting from the collection, processing, labeling, and validation that would be finally used for training a data or even evaluating, training the model or evaluating the model. So let's dive a little bit deeper into how the industrial and academia see about data is gold. Here is the GPT-4's technical report, where they mentioned the key information about what the GPT-4 involved regarding data, methodology, modeling, evaluation, etc. And here you can see that they have also highlighted the scope and limitation of their work, where they said that the model was then fine-tuned using reinforcement learning. And here they especially focused or highlighted that the model pre-trained, they are using both publicly available data, such as the internet data and the data licensed from the third-party providers. So currently, as long as I know that the OpenAI were related, Anthropic, those related LM, big tech companies, they primarily use two sources of the data. The first one is just scraping from the online, such as Wikipedia or some books or etc. And the second source is about they especially have some contract with the third-party data companies, such as Scale AI, etc., so that they could tailor for what they want for their model training. So that is how current ways the big tech companies get their data. And then here, some of the companies they are also releasing or having some blogs or having some articles saying how or showing that how they would use your data for improving the model's performance. And here's just updated 18 years ago. There are many, many blogs and articles that showing these kind of details. And here's another model, Llama 2, which is actually an open foundation models compared with GPT, which is a closed foundation models. And you can see that on the in the Llama 2's paper, they said this is an updated version of Llama 1, of course, and trained on a new mix of publicly available data. We also increased the size of the pre-training corpus by 40%, double the context length and the model. So you can see that basically most of the company improved they improved their model by primarily, they have several strategies to improve the model. The data is the very, very, very important like aspects for improving the model.
When they use like public data, do they do like filter or do they like double check whether it's good or it's like a little bit not good to
biased? Like contaminated. Very, 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 very great question. So I also have the figure like later showing some more details for the companies. Like I believe they will have very strict process of doing the filtering, basically pre-processing on the data, so that after they scraped the online data, because the online data usually has many biased or contaminated content as well, such as some like harmful content, and the platforms they usually get the data, like these publicly data are sometimes from Wikipedia, where we know that Wikipedia is not very objective as well. So they also have their political opinion, etc. And also maybe from Reddit and from some other online forums where there are a lot of harmful content. So they definitely have some strict process of internal filtering, internal like monitoring, etc. That's a very good question. And here you can see, I believe all the companies, no matter it's an open source model like Llama 2 or closed source model like GPT, they will have this filtering. And yes, here we can see that this is a figure regarding giving us a good example or specific example of how or which status the data will be involved for improving or training the model. Here's one process of doing the RLHF, where you can see that they would start from pre-training data, and then this data is actually already filtered, cleaned after the process, and then they will be sent into the self-supervised learning to improve the Llama. This is actually the figure from Llama 2 as well, so that they show the process, how they develop this process, how they develop the model. And then this fine-tuned model would be like fed or using on the Llama 2 chat. And then they do this RLHF. During this, they also have another places that need the data, which is human feedback for improving the RLHF, like human feedback for reinforcement learning. So that's why you can see that they would primarily need two data aspects or stages, where the two data is actually a little bit different for the format as well. But we don't necessarily need to go in deeper. But here you can roughly have the sense that the pre-training data is primarily scripted from online, like Wikipedia or etc. for these. And then this human feedback is something specifically tailored for improving model's specific part. So that is another part for data with another format. Yes, so here's the process. And
sorry, I ask a question, like for the pre-training data, do they process it with a large language model, or do they process it with like conventional database approach?
Yeah, you mean like process
pre-training data, I mean, yeah.
Yeah.
Data, how do they
process that, right?
Yes.
So for the pre-training data, they have different ways. Some are rule-based, like they script from the online and then like storing at the local database, and then they could do with mixed method of doing the processing. Some are maybe from rule-based, such as like keywords on harmful content, they just directly throw. And then they might also have some like machine learning classifiers to identify this is a hate speech and this is not, so that for hate speech they would filter that, or some misinformation.
So I mean, but like the computation resources in this step is pretty like comparatively small. Right?
Yes, yeah, exactly.
Yeah.
Especially comparing with if you want to train model.
I never know how a model can do a self-supervised learning. I mean, how can the model like supervise himself in the early stages, right? I mean, this puzzles me a lot.
Yeah. That's a very, very great point. I also saw like there's some directions where there's actually some topics about self-improvement on data augmentation. So that there, if you like search for these related topics, yeah, self-improvement on the data, like on data augmentation related. Later on, we would also cover that. That is the most of the topics or related ideas that they might have another LM or have themselves in some way or have a teacher LM to do as a simulator that could monitoring the data and then do this in a dynamic way, evolving way.
I heard the word called distillation. Is basically this stuff.
Yeah, distillation is a broader like the word as well. You mean like when you heard about the teaching and students, there's something distillation. But for that case, like it's more like the teacher model or another monitoring third party model, let's say, are doing a monitoring role for like monitoring the process of generated data and do something of filtering such as like etc. So we can probably cover it later, or you can search it in depth if you're interested.
Thank you.
Yeah. No question. Great. And we might be interested in, or like we need to confirm or understand when do we need data for a model, AI model? And here are some typical process of the model development, including collect data, storing data, process data, train the model, and monitoring the model. And we want to highlight that data is so important because all the stages need the data. So yeah, any questions or comments here? Great. So now, in like, for the transparency of the larger model or broader AI models, there is a more and more common rules showing that the big companies need to release their model specification or the model details so that the public could know better about how the model was trained. So this is from like September, very soon, like last week, from the OpenAI's website there, where they released many of the details about GPT, how the AI models were trained. And here is one thing also good to answer your question, that they actually did some processing on checking whether the content are violating their rules or not. So here's one example that they asked the LM or assistant to generate something. And there's like, they did actually some inspection or monitoring on checking whether the generated content are compliant or actually violating some content, violating some rules, such as generating harmful contents, risking content as well. So you can see that they are doing these kind of inspections when they training and developing this model. And you can also see more details about this in this in this link. And here, this is another one released from OpenAI, where there are more and more media, like coverage, or more and more institutes wanna critiquing the large model, saying that they are actually violating some copyrights or using some of the sensitive models. So that's why more and more companies are doing or releasing some blogs or articles saying that how they are responding to some media's like demands on releasing their data, transparency, etc. This is one article from OpenAI in June this year. And this is also another one from Anthropic, where they released a week ago showing how do you, how like we are using your personal data for improving the model. So you can see that the big companies are releasing more and more, or emphasizing a little more attention on the data while they are using for training the model. And here is a good paper. I think it's very, very helpful, releasing this year, very soon, 3 months ago, which is a good summary about the data for LM. So if you are very interested in the data part of the model, feel free to check this paper. It's from like a collaboration of Shanghai Jiaotong, Tsinghua, Shanghai AI Lab, and Alibaba. So you can see that here is the overview where I think it's a very good summary about the data parts and used in the LM. So we can briefly go through it. You can see that this is the data, method, and product regarding where or how they are or what the source they are generating the data. The very raw resources they are using is like some original platform such as Google, Wikipedia, GitHub, etc. And then they are using some method to acquire this data, such as like data collection, data filtering. You can see that they are not directly scraped and used. They actually did a lot of process, which is actually a pipeline of data processing. And then these filtered data would be maybe stored or like saved in some open data platform or database, such as like a Snowflake, Alibaba's product, etc. And in the meanwhile, you can also see that the x-axis, the data is relevant in different stages of the model as well. So you can see that data would be used for training the model, and it will also be used probably for model like some part of the model, and which is new, I never covered before, is about the RAG. So currently we know that the GPT or these big models are not only directly generating. Before they generating the final generations, they are actually also doing a RAG, which is retrieval augmented generation, meaning that they actually are combining what they can generate with searching some online resources to get the final results. So that, for example, if you consider that the model was trained with only data before 2024, then whenever you ask the model something about the 2025, the model couldn't know, right? So that was the limitation of GPT like years ago. So how they addressed this problem that the model won't know the things that happened yesterday, they basically combined their generation, which might be trained only with 2024 data, with a search engine, so that the model could search for the latest news, even just happened 20 seconds ago. So that the model could combine both resources to generate the more truthful results. So that is why the RAG was introduced and improved the LM's generation very significantly. And then here's also inference data and etc. Here are also some example data sets that was being used in training or improving the data, the model. So here are the overview of them. And I also dive a little bit deeper into this paper that you can see they have different stages of the model that involving different types of the data. You can see for pre-training data, where many of you have also asked, here are different data sources from Wikipedia or from arXiv for some paper, or from GitHub, which needs some codes, and then just different formats and different resources. Usually a very, very huge database for pre-training the data.
What is the 74.2% is the largest?
Yes, which is this I think, not here. Yeah, it's actually one of the place. Yeah.
Is it like from the web?
Yeah. It showed in the paper, I couldn't see these details. Oh, it's a common, yeah. Common crawl. So that is like one of the data sets that has been used.
Is it like an open source data set, or it's a service provider
Um,
crawling services?
honestly, I'm not very familiar with this. But I think that as it is a data set, I think it's a published or public data sets that's great or collected different resources, because this is not like first-hand resource. First-hand resource is more like directly the Wikipedia who generates the content, like archive which hosted all the papers. But I think this one is more like a container that's like, incorporated all the places. So they might use many of the resources here. Yeah. And yes, so this is for pre-training data, which is one of the most important aspects for improving the LM. And here is continuing pre-training the data. This is also an emerging topic for LM, saying that continuing comparing with pre-training data, you can see even though the model was pre-trained and fixed there, we still want the model to have some learning capability. So that's why they are saying, or this continuum pre-training data was being introduced for having a lifelong of learning capability. And then here's the supervised fine-tuning. You can see they have some usually a smaller size of the model that would fit for specific task. You can see here, this is the QA, questioning and answering related task. This is a capturing related task. So that you can see the pre-training is primarily augmenting the model's general capability. So that is also named AI, like artificial general intelligence. And then this supervised fine-tuning data, the goal here is to augmenting the model's specific tasks capability. So they are actually serving with different goals. And then reinforcement learning is taking furthermore to improving the model's alignment between the human's preference. So that's why it is mostly like reinforcement learning with human feedback. So it makes the model to be more aligned with humans' values, preference, opinions. So you can see 3 places serving as 3 different goals when they are using data. And the format here, especially for reinforcement learning, is a little bit different as well. They are mostly using something about ranking and rating, compared with these are just brand like raw text-based paragraphs. So the format is also a little bit different. And here is something, here is like instruction learning related to LM reg data, which is used for retrieval and answering the user's request. And the agent data is even higher level, that if the LM agent would use the data, they could have another data sets or some format to be used. Here's some good overview of example data characteristics across different LM stages, from pre-training to the LM agent data. And here is some example LM data distributions they have conducted, saying that regarding different stages, what the key topics would be involved for data. And you can see that for supervised fine-tuning and the task related to general, the most relevant one is about Q&A. So open source, open question answering and closed question answering. These are the primary type of the data, and etc. We don't need to dive deeper, but you can see that different task, different topic are using different distribution of the data and even different languages of the data. So there are some, then we need, as also one of our classmates just asked, that the pre-processing or the processing of the data is very important to ensure their quality and the safety. There are actually some key principles that they have summarized during this processing process. And the key principles involve that when designing data processing pipelines, several critical factors must be considered. The first one is the trade-off between data quality and quantity. Usually, if we have a stricter filtered rules, the data would have like less quantity but higher quality. But if we have a loose rule of filtering the data, it will usually have a lower quality but much larger like quantity. So that you can see there's a trade-off between quantity and quality, and also the dependencies across the processing operations, the efficiency of the optimization, etc. So processing the data also have a lot of decisions when you want to make this. So you need to consider in practice. And here are some typical pipelines. We don't need to go in deeper into that. It's very complicated, but I want to share with you that if you are interested in knowing the pipeline of the data set, then going through with this. Yeah. Question? Yeah, this sounds like a little bit out of our scope, so that we don't need to cover this. And here are all about data and why data is important. Any questions? Good. Then you might be interested we're interested in how do we collect the data for LM and the training. Here are some, we would cover the representative of data collection here. Before we going into the second section, I would love to hear your experience or your thoughts about what methods can be used to collect the data for AI-related studies. For example, if you have ever conducted the AI-related projects, how did you get your data for training? Share your experience.
For example, like last year, we are trying to train an AI on music generation, and we searched on Bilibili for some piano playing videos and use a specific like MIDI extractor to extract all of them, and we get the data, for example.
Great. That's a very good example of scraping the data directly from the source, like Wikipedia or YouTube, so that you can get multimodal data, including video, including video, and including maybe some text if you have caption, right? Cool.
I think like many studies just use HCIs to like ChatGPT to speak and do prompt learning and just generate some data. And some also like there is sometimes they will tune their own model, like using like tuning method recognition, and also sometimes some rule-based communication based on the structure of the data.
Yeah. Very good. So this is a very good example about like simulated or LM in the loop, augmenting or generation of the data, which is more and more common nowadays as the LM's power is actually, or capability of generating data is higher and higher, so that the people tends to more and more use LM to generate the data and do some rule-based filtering to ensure the quality. Yeah, that's also a very good example. Great.
I heard a lot of startups in Silicon Valley, they hire people to generate data, and they like for high quality data, they actually screen resume. But for lower quality data, they just outsource them to like third world countries and let those people to like label them and stuff.
Yeah, exactly. That's another very great example as well regarding human in the loop annotation. Yeah, there are some startups that, for example, Scale AI, Prolific, that they are specifically working or like their business is primarily like a human annotation, and that they are actually directly serving for these big companies such as OpenAI, Anthropic, etc. And the human annotation was high quality. Actually, they not only like hire people from US, because US employment is kind of more expensive. They also hire people from other countries. Yeah, maybe not a lot of China, because they might need some English speaking country to do some of the task, but they're actually recruiting the annotators from all over the world with all over like different languages as well. So that is actually an emerging trend of the third party human annotation companies to support the data as well. Great. Yes, we actually covered most of the methods. Really great job. And usually the typical methods for AI development, including the web and the data scraping, where we have just shared. And the second one is human in the loop annotation, such as from the startup companies, and human AI co-annotation, and the synthetic LM simulated data annotation, as we also like mentioned here. So pretty comprehensive answers, very cool. And we would dive a little bit deeper into each of them. for the web and data scraping, which is actually the main resources for pre-training data. And there are many different like resources we can see, such as Wikipedia, Britannica, Reddit, Stack Exchange, GitHub, etc. These are primarily for coding related tasks. This is primarily for maybe Q&A, and this is primarily for like normal knowledge and etc. So you can see the companies are fully leveraging the online resources to get various of the data knowledge to improve the model. And here you might need to know that if you in the future will script your own data and release it, you also need to consider about the license here, so that you have to have a data license, and then that could help you to hold the copyright of the data, and then you release the data. This is another thing you need to consider. And for these cases, another key, if we just do a research related, we are not opening our own OpenAI, we're opening our own startup for ALM, then we can just directly do some easy things, such as like there are some online data sets we can directly download and leverage if we just focus more on the model part, and we want to do like take it easy for the data part. And you can see that Hugging Face, they are hosting data places. You can see they actually not only host the data sets, but also host many trained or fine-tuned models here. And they actually have over, yeah, you can see 500,000 of data sets for your choice. And the data are including different modalities such as 3D for maybe AR, VR related tasks, audio for speech, document for text-based, and images for image-related models, and video for the video-related model. So if you might need some research or future projects and you need some immediate like data for trial and error, feel free to take a look at the Hugging Face to see whether we can get your own data. And it's very easy to use the data. First of all, let's see the format here. The format of the data is usually for text-based, it's just a tabular, where you can see here are the key content, here are the key prompts they used, and they might also have some meta labels such as what time they just scripted these data, and who are the like maybe the people generated regarding their demographic information, etc. So this is usually the data format for a text data set, for example, here. And then what you need to know, and it's just like using some very easy Python lines to download this data in your machine. And there are some key tools in the future if you need that could request this data, such as some Python libraries, especially if you need to script from online and from the website. Beautiful Soup, Scrapy, or the Selenium are very good tools you highly probably would meet if you do these related tasks in your research. And there are also some platforms that they could help you do these data scraping, web-based tools, and also some browser extension if you just want to do a parser, and then you can directly download the extension to help you do this scraper, so I can save your time.
I have a question. I mean, with so many data sets here prevalent online, I mean, why should we like scrape our own data if we don't want to create a new data set? Is there any cases we do need this, because it's kind of tedious process and a lot of dirty work?
Yeah, that's a very great question, and practical question as well. So I think the main rule or decision would be made by whether there existing data set that could satisfy your demand on the task. Say most of the tasks, if we don't have very novel contributions on the task, then most of the case that the data sets are already there for your choose for like the model training, fine-tuning. In that case, you don't need to script your own data. Like, so you can directly go into for example, Hugging Face, the data sets, and find your own related data. And which data set would you find? You might be interested if given like thousands of the data sets. One good way is to look at the prior or state of the papers published relevant to your research or your research question and see what their data set they are using. And then you could primarily like search for those data set as your benchmark or as your task to start with. So that is a good way of where to find the relevant data and which specific data you want to use. And regarding some new data set that you have to scrape, then you could using these ways too. So for example, if you have very specific task on, you want a super long book that related to a very minor like the language that is very rare, and then you might need to specifically search like or generate or scrape the data from that specific languages like websites. Yeah, so that is, you know, unique case. Yeah.
And also they asked about like I heard there's some like legal caveats in like scraping because like I heard that for Tencent and Xiaomi, they might prosecute the data scrapers with like 破坏计算机系统罪。
Yeah, that's basically you're saying that there are some actually sensitive or like the scraping the data is not always allowed. There might be induced some like illegal issues there, which is true. So that's why at the very beginning I mentioned that you might need to check the licenses or copyright. And actually some companies, especially online website, they already have some solutions. For example, if not solution, they already have some wall that you could not feel free to like scrape. For example, some website, they would like constrain how frequent you scrape the data so that you have to make your Python scripting code to wait or sleep for several seconds so that they cannot detect you directly. But yeah, I think this is like the most important thing maybe is that when you scrape your data, you need to check the personal or privacy information, you have to remove those. So there's one thing named the PII, like you can check it. You have to remove those privacy information. That definitely is illegal. So that is one thing. Second one is related to which resource you want to scrape, and then checking out whether the raw resources like policy or their rules, so that you don't wanna violate their legal related requirements. Yes.
Is it possible to like for example, I found a useful Hugging Face data set, but I don't think it's good enough. I watched it and I re-upload as a fellow of it. Can I do this?
Yes, yeah, you can definitely also do that. So one of my previous project was actually like it was published in EMLP 2023, where that was we want to create a new benchmark, but that benchmark is not scraping data from the very beginning. We are actually on top of another like existing data set. So basically existing data set has already like a single term related disfluency, like those kind of annotations. What we want to do is just multi-turn. So now you can see that we are actually just doing on top of the originally single turn one and adding some new functions, which is exactly one example of what you said. So what we actually did, we just processed on the same data set. And then when we release these data, we have to like calling the originally license of the data. And we also have to like going through the internal of the company or the university to saying that, okay, releasing the data would satisfy the data copyright or things. So they actually have to have a legal processing legal checking process. Yeah, for that case is because we are in Google and they actually did a Google internal checking on the copyright. So yeah, that is something you want to double check, because if you are working on some prior existing data set, which is primarily which is most of the case already have some copyrights or license, you want to double check if your outcome or your new contribution on the data set would obey the originally license. Yeah, good. So here is, we have covered about the scraping data from scratch. And then we also have some the answers related to human in the loop annotation. And human in the loop annotation is very, very important. When years ago, there's no LM, the data generation is not that good. For example, ImageNet. ImageNet is a very good, successful example of human annotation. They actually annotated the ImageNet from Amazon Mechanical Turk, if you know. And Amazon Mechanical Turk was a crowdsourcing platform, which is like a platform that they have a lot of annotators, which everyone could register for as an annotator. For example, you and me, we could all register from an Amazon Mechanical Turk annotator. And then there's also Amazon Mechanical Turk requester, so that it is kind of free matching platforms for these data annotation. What if you are a researcher, want to release your task for any people or some satisfied or qualified workers to annotate your data, you would just creating your own either website for hosting that, or they have some pipeline of releasing your data step by step. They have a website to do these so that you can release your data, allow the Amazon Mechanical Turk workers to annotate using their website to do your task. So that was a very important and popular platforms in the past years, such as, and many great data sets are from them, ImageNet, etc. And nowadays, things there are more and more emerging number of startups are actually doing this data annotation very professional. They are actually hosting their own data annotators. So that those data annotators would be usually a higher level of quality after some pre-screening after the company, and they are also paid for generating high quality. And that's why some emerging startups like Scale AI, Prolific, etc. And then nowadays, many academia people are tending tends or resort more to these platforms to get the better data in a relatively short time. So that is some of the history of these data annotation platforms.
Are these platforms still massively existent nowadays?
Yes, you can still do that. Yeah, for pros and cons, Amazon Mechanical Turk was very fast because they have a lot of workers, very active users, but the quality is usually pretty low. Although you can have some screening process, but you see everyone could register as an annotator. That also means that most of the people or many people just want to get the compensation of the annotation, but not the quality. Yeah, that's the pros and cons. For the later on, these new startup companies, they usually might take a little bit longer time, although they are more and more efficient, but their quality is usually much higher, but more expensive. Also more expensive, yeah.
Yeah, well, do you think data broker is a good business idea now?
I'm not very familiar with these business, but you can feel free to check online, search for whether they
Yes,
there are also some news related to some CEO of these big data companies. They have also changed their career path so that you can search for these related news, which is very fun as well. And regarding the human in the loop, I would give you one example about how to do the human in the loop. So this one, currently, I think the most easy way, if you want to have your own data annotation and own data generated one, it will be much easier to just two ways. The first one is if your data can be designed into a survey, then you just put them into a survey like a Google form and then spread them on Prolific or on some open platforms so that you can directly get your data. You don't need to design a very complicated pipeline. Or if you want to do more complicated one, for example, multimodality or more complicated interactive annotation, you can design your own interactive interface and then host it into the Prolific or other platform. You can get more complicated data for these responses. But back in years ago, where these emerging startups are not that popular, we're still using Amazon Mechanical Turk, where we want to have quick and the lower expensive data meanwhile have a higher quality. What we did was that, first of all, you can see we basically designed the 4 stages of this data annotation. You can still refer to that. And then the first one and the 2 steps was that you need to design an interactive interface so that the users could log in or access your interface to do this kind of interactive annotation. And usually the first version of your UI where your interface is not ideal or not that good. So what you need to do is to do several pilot studies. And in these cases, or in this project, we actually did 7 pilot studies to optimize the user interface design. And then after hosting the data set, usually our annotation task would have some difficulty or might need some expertise to conduct or annotate. So that's why you want to select qualified annotators for your task. So that what you can do is, first of all, just design one qualification selection saying task, and it's very simple and it's very quick, and you can spread the saying to request for 500 or 1,000 of the responses. Where you have a ground truth, you can filter about the quality of the responses from the worker, saying if you set the F1 score of your ground truth as at least a threshold of 0.6, then you can filter out or remove all the annotators who just like give the F1 score less than 0.6. So that after maintaining this pool of the qualified workers, you can then do these kind of formal annotation studies, where a more safer way we would encourage is that do not release your data, sometimes maybe like over 1,000, 10,000, or 100,000 of the data immediately to all of them. Instead, split them into small batches, like 1,000 per batch, 1,000 per batch, so that you can just like release each batch every time. In any case, there are some risks or there's some errors, you can just modify your small batches. So the influence of each batch would be relatively small. So that is encouraged solution or practice you want to do, you might consider to do in your future study. So this is the interface we designed. Be aware that usually you need a very long and detailed instruction to teach the annotators so that you don't need to interact with them. You just want them to read carefully about the instructions and then know how the task would to do. So there are actually a lot of beauty or a lot of like practice or experience in designing this UI as well. But that's not our emphasis today. So now we know how we can script the data directly from the Wikipedia or online source. We also know how we can collect the data directly from humans. More and more study and research are now focusing on human and AI co-annotation or LM related driven annotation as well. It's mainly because due to the increasing power and capability of the large model. So you can see that this is a paper published in 2023 where they, let me see whether I have yes, this is the paper's title. You can see co-annotating uncertainty guided work allocation between human and large models for data annotation. So this is a very pioneering work on designing the mechanisms of how human and LM could collaborate on annotating the data. And here's their philosophy here. So in the previous evaluation or task, we usually consider that different data set, if the human is outperforming the LM on some task, then we just directly recruiting humans to do the annotation. But if in some task, the human is less capable than the LM, and then we just recruiting or leverage LM to do the annotation. But this is not fully leveraging the advantages of both, because we know that human usually have higher quality and the LMS usually have lower expensive but higher efficiency as well. To fully leverage the advantages of both, what they designed is this uncertainty driven of co-annotation. So the philosophy is that if we already have an instance, basically one data example or one data set, and then the LM might have some like generation together or along with their confidence or along with your probability. So they can check that if their probability or if the LM is super confident on the generation, then they just directly give it to LM for the generation. But if the LM is not that generated well, not that generating well, or they have actually not consistent generations, then human could be in the loop to addressing those kind of specific instance cases. So you can see that you are not purely rely on just human or LM. You're actually leveraging the quality or the benefits of both of them to do this human LM co-annotating. Sounds good? Any questions?
So my understanding is that like the confidence score is basically like instance level.
Yes, exactly.
So
One by
for-
one.
So for instance level, if the confidence score is, for example, like smaller than 0.5, it will choose like human annotator for this exact instance.
Yes, yeah. And it doesn't mean like the second instance will still have the same. It will pure or primarily depends on what's the instance probability, each of the instance probability. Yes.
So how do they measure entropy?
Entropy, right? So when you use your large language model to generate or do the generation on the task, you can usually have the probability of that specific generation, and you can compute their entropy based on this probability score.
Like, sorry, like how do you calculate these entropies? I mean like entropy with its own definition. I mean it's like the how sparse the probability is, right? And well I don't know like how they measure it.
Yeah, so that's also a good point. They actually did multiple generations for one instance. It's not directly like a probability higher or lower. They actually did multiple generations and using the pool of the generation compute the entropy.
So is it like it has a task and it asks like the LLM to generate multiple times and see how different each output is.
Yeah, each focus on just one instance and multiple outcome and multiple generation, and then compute the entropy in this case and set a threshold to decide how to go.
Oh, okay. So like, but I mean like in this case, it must be a very close-ended, like it's not open-ended questions. It must be like answers are in a
Ground the
box
truth in some way.
set. Yeah.
Not necessarily. I think even though the generation is not ground truth, there is like a binary yes or no. You can also see even though it's open-ended generation, you can still see like how diverse the result is. If let's say that it is super diverse or it is super conservative, like a convergent, then you can decide based on what strategy you want. So it's not necessarily only ground truth or closed results.
I also see it also seems like they only generate answers from OpenAI, right?
No, that is just like for figure or example for their experiments. Yes, they just use OpenAI.
I
But
think I think people do they generate with multiple AI agents or LLMs like from a lot of sources?
yeah, that is also a good point that you can using different models to generate and see. Like basically we have a committee of the generation and decide the annotation. That is an extension of this work, but not exactly this work.
Thank you, but like I mean like if the answer is not multiple choices or true or false, instead it's like an open-ended question, this doesn't work, right?
I think it can, as I just also said, like it still can work, the open-ended question. Yeah, it's this one is about human AI co-annotation, and it's all about when you should use LM and when it should use human. So you can specify that if the open-ended question you need is very divergent, then highly probably you might need human to be in the loop to answer that and check that, so that you could not completely rely on LM. So it's more about when you should use AI or human. See. And I guess your like we can probably skip this. It's still the same paper and with more details. Your question might be more related to when we purely use LM without a human, then how would we deal with these open-ended question? Yeah. If it's pretty open-ended, then you're just having human in the loop to double check.
Yeah, but I mean, like, I think human in the loop causes another problem. It's like how to evaluate these students, because humans don't always give you like correct results. Right?
It also depends on what task you are using. If the task itself is no correct or wrong answers, then it's hard to evaluate. There's also an emerging like topic. I recently read some papers that some researchers are advocating that though there are some cases there's no ground truth. So for example, creativity task, there's no ground truth for some creativity task, so that it is nonsense to have a benchmark for creativity task. Although that is actually common practice that the academia is using. So there are some debating on whether we should have a benchmark for a creative task. So I think that is like still an open research question nowadays, hard to answer for this. And let's come back to continue our lecture, where this is another one of human and AI like collaborating on data generation, where I want to provide more examples for your reference, because like in the future, you might also need some tasks or the research projects that generating your own. So for this paper, we mentioned multiple times, this is like our EMLP 2025 paper, where we want to generate the value related data set. We want to have a value related data set for evaluating whether the LM is lying. And then we realized that there's no existing data sets for that. So that's why we designed this human in the loop data generation with the help of LM. So what we did was that we have, first of all need to decide which prompt is the best for generating this large scale of the data set, given that a prompt is really very inconsistent. And then we designed 8 different prompt variants, and then involving 2 human experts to rank the 8 different prompts. And then based on their ranking on a subset of the generations, we can find the optimal prompt, which in this case, as you remember, was the prompt 6. So that this is the first time we would need a human in the loop to decide which prompt is good and whether the prompt is actually consistent. And the finding for this one was that actually the prompt is kind of very stable, and it's not that stable as we want. Half of the prompt is with very high performance, like over 90%, but half of the prompt is actually just around 50%. So it means like a prompt indeed matters in this data generation case. So we need a human in the loop to verifying which prompt we need to use. And after generating the specific full data set within the optimal prompt, we need a second place to have human in the loop, which is the final data quality evaluation. So that's why we have another set of data annotators specifically check the data quality, where in this time, we actually hired a bunch of people from the Prolific across all over the world to see whether the generated data is aligned with the specific country, is aligned with the specific like task and the culture as well. So these are one example of when we need the human in the loop and whom we need to have for generating our data. And this is the prompt we used. You can take a quick look at it, where we specify the different country, places, and generating with different ways. So if you need prompt examples, feel free to take it. And here is another very good example of human LM collaboration annotation through effective verification of LM labels. So some ideas similarly that you can see here is they also want to leverage the LM's capability of the data. where this is to some extent similar to the co-annotating papers idea or philosophy, where the idea here is that they just using the LM to annotate all of the data, and then they set a verifier or a policy or a requirement to filter out which data set are with high quality and which data set is actually pretty low quality. And then they have those low quality data to be annotated again or re-annotated by the human, so that in this way they can ensure all the data would be good. Yes. So that is also a good method or approach to ensure a good collaboration between human and AI. Yes. And this is also some prompt examples, because in the future you might need prompts to do a lot of generation, like also your experience. So feel free to take a look at, refer to these prompts that's shown in our lecture. And here is the synthetic LM simulated generation. The synthetic LM, synthetic data generation is more and more important and emerging in the research community, because people want to fully leverage the capability of LMs. And then this is a good paper, or this is not a paper, this is actually a tutorial for what is synthetic data generation using the LM. And here they actually showed a pipeline of the architecture, where I think that I didn't use a lot for these synthetic, but the idea involves some of the idea you just mentioned, the self-improvement. There are some like things related to self-improving synthetic data generation in this process, where you can see that the quick idea were like, we don't need to dive deeper here, but the key idea is that they have some knowledge base that they want, and then they chunk the knowledge base into small pieces, and then using some random selector to get the chunks for these content generation. And then they also have some like generating with different or selecting with different and the most similar chunks, and do this query generation to this evolver. And this evolver would involve some self-improvement that we just mentioned. And then finally, this is the synthetic data set. I think I didn't see quite that much papers related to this, although they might be like promising to some extent. But there are definitely some issues you need to concern or need to keep in mind when doing this synthetic data generation, where, well, when generating synthetic data, there might be some issues that the queries that real user would never ask, so that when you do using the query to generate what you want, this query might never exist before. And the task sets that don't reflect actual usage or wasted effort optimizing the wrong things. So that basically, in short, in synthetic data set, you need to ensure that the synthetic outcomes would be relevant or similar to the real world distribution of the data, regarding like the key meta information, demographic reflection, etc. So I think these are still an emerging domain or topic. I haven't seen a lot of work, but there are indeed some, like this is a GitHub, open GitHub that you can use it. And then this is some tutorial on that. This is one, I'm not quite sure whether it can be synthetic data, but this is a good paper I mentioned multiple times, that Google is using a LM like model to do red teaming on another LM. So basically it is using the LM as a simulator to double check or check the safety of another LM. So the idea here, basically can see that if the originally red teaming LM would generate something like potentially have harmful content, like releasing some sensitive user information or data leakage or offensive content, then common of the case that there would be a real human, such as like there are many big companies, social media platforms, they would have a specific department or group of people doing like checking misinformation, content moderation, etc. So there would be in previous practice, a group of people doing these kind of checking or content moderation on this thing. So what in this paper they are proposing is that we don't need a human to do that. We need another red teaming LM to do that. So the LM is more like a human proxy and a human moderator, a simulated human moderator to do these red teaming tasks. So this is their philosophy of this paper. And if you are interested, feel free to check the paper in detail that was published in 2022. So a very traditional paper. A very classical paper, yeah, has been published for 3 years. And here's a good example, good summary of all the typical data collection methods we just covered here, where there are methods of web data scraping, human-in-the-loop annotation, human AI co-annotation, and synthetic data generation as well. So I summarized the description here, the pros and the cons, and some typical use cases. And if you in the future need to find what would be the best way for data collection, feel free to check it out. Now we want to quickly cover our data validation and consensus building. The consensus building is very important that in the future, if you have some new data relevant in your paper, it will be very important to release your IRR, like iterator reliability. So here I want to share with you some methods to do that. Now the first question I want to hear your thoughts is, now consider the cases that for each instance, we might have at least multiple annotators to annotate the same case. Well, there might be some cases that for image classification, let's say, some people might say, oh, this is a cat. Some other people might say, oh, this is a dog. There's always the case. There's disagreement between the annotators. How would you deal with it?
That's the question I asked about.
In this class?
Oh yeah, like before, yeah.
Yeah.
Like humans could make mistakes.
Yeah, you mean the disagreement?
Yes, I mean there might even be some supply chain attack, I guess.
Yeah. So this is yeah. Yeah, this is professionally named aggregating the human annotation. We're aggregating with the different annotations, no matter it's from LM or no matter it's from human. Having multiple one is to increase the quality or the robustness of the annotating, but aggregating all these different one is another way of, because finally we only have one label for that. Do you have any thoughts about this?
Yeah, you could do like a majority vote or some sort of other combination. Or maybe if there is like a human and some AI annotators, maybe you choose to prioritize the human's input, but it could be, yeah, either of those.
Yeah, that's very, very great answer and covering multiple strategies, which is pretty good. So here I'll share some of the typical answers or solutions, where as we see that there are already some techniques and in the pre-stages way, before we do this data annotation, one way or solution to mitigate these potential disagreements is that we need to identify some systematic biases, which is hard, but if that's the case, please identify some systematic bias. And what we can pretty sure do is clarifying our guidelines and clarifying what we need for the specific data annotation so that everyone are on the same guideline, so that the more clear and the more consistent your guideline is, the higher probability you get the agreed annotation. So that is something we should do in the pre-stages of our data annotation. And after, in the post stage of our data annotation, there might still be 90% of the case that the data has some disagreed label. And then what we could do, yeah, then the first one is majority voting, which is pretty good. Usually we have an odd number of annotator, like 5 or 7 or 9, and then you just do majority vote. The second one is about weighted voting, saying you can give different annotator some of different weight based on maybe how accurate these specific annotators, like how qualified they are, and they gave different users or annotators as different weight. That is another one. Or there could be some other methods that you can have a third party or higher level of experts that could specifically check those disagreed cases and then hire an expert to address these disagreements and etc. You can do iterative feedback around, and there are multiple ways you can address. And then dealing with the disagreement, looking beyond the majority vote in subjective annotations. Here's a paper published back in long ago, like 2021, but it's a good, very good Google research team that they have also discussed, investigated how we could deal with it. And they specifically using a model that could deal with or like categorize the different case of the different labels and how they could address. So feel free to check deeper into this paper. And then what I want to cover or highlight is about how we could compute and show the agreement of our data annotation. Usually for each of the case, we have multiple annotator or annotation results. We kind of need to show that our data is with high quality because all our annotators are actually with a high agreement so that this label is kind of robust or reliable. And how could we show that agreement? Here are different inter-rater reliability methods or statistical ways we can compute. It is also named IAA, like inter-annotator agreement. Basically, whenever you see IAA and IRR in the human annotation case, they are the same thing. And then here are 4 typical methods, statistical methods we can use. The first one is joint probability of agreement, which is the most simple one, but the less robust one. And the second one you might have heard a lot, like Cohen-Kappa or Flass-Kappa. The Kappa one is a very traditional and widely used way to compute their IR. And the third one is the named alpha one, like Krippendorf alpha. So this is another one of dealing with different type of data. And the fourth one is correlation coefficient. That is basically these 3 are more robust, dealing with different types of data, and we can cover later. For the first one about joint probability agreement, it's just percentage of how many agreed versus how many disagreed. It's very simple, but very the least robust in this case. And then the Cohen-Kappa is basically, I want to compare the kappa. They're mostly involved like 2 typical kappa way. The first one is Cohen-Kappa, where you might have heard the most about. But the thing is, they only involve 2 annotators. If you have 2 annotators do an IRR, you can use or report your Cohen-Kappa. But if you have multiple annotators who want to compute your inter-rater reliability, do not use Cohen-Kappa. You're making a mistake using this Flass-Kappa. So that you might want to keep in mind and do not make these very simple mistakes in your research paper. So that is about kappa. And here is how to interpret the kappa score. Usually it's from 0 to 1, and the higher the better. So at least if you have a kappa score higher than 0.6, we can consider it as moderate reliable, and the higher the better. So when you have your score, just read it in this way. And you can, now many packages you can compute the kappa. You don't need to compute manually from scratch. You can use Python, MATLAB, R, any packages to compute this. This alpha, Krippendorf alpha, is another like alpha related measurement. And this correlation coefficient is another measurement. So I want to directly jump into this one because this figure showed what's their relationship and what's their difference. If your annotation labels are nominal related labels, then you use Cohen-Kappa or Flass-Kappa, depending on how many annotators you are annotating that specific task. Then if your data is actually, or your annotation is ordinal one, so that is more like a ranking, and then you might want to use these Candace tau. So this is a better, more appropriate way to report your IRR. Or if your annotation is actually a metric, then do not using these two, using the Pearson correlation. or correlation related one, so that this is more accurately reflect how reliable your annotation. Yeah.
A quick question, I mean,
Mhm.
like, don't want to dive deep in them, but it seems like handling disagreements, we can use it with entropy, and so I want to ask like, how are these metrics better than entropy?
That's also a good point. You can use entropy, but there's no like we just interpret here. Like we can use a specific score. The kappa is very strictly from 0 to 1, and entropy is actually no specific range and limit, right? If we have the entropy saying it's 0.88, what does it mean? So it's very hard to interpret. But for kappa score, they have very clear interpretation on what range, meaning how reliable you are. So that I think this is a more well-studied, but if you can develop a theory of mapping entropy to the IR.
Actually, I recall a research paper you shared earlier, which is like annotation, like if some metric is smaller than 0.5, go for AI, and some metric larger than 0.5, go for humans, and they use entropy. I mean, like, why don't they use this metric?
Yeah, because the entropy you see these human AI co-annotating paper, because that threshold is very subjective. I mean, that is a philosophy, a method of the paper, and that threshold might be very depending on what a specific task. But for here, if we want to do IRR, it is universal rubric that applies for any of the tasks. You couldn't say, oh, for this task, the IRR is 0.8, it is good. For that task, the IRR is 0.8 is bad. You know, we need a universal one, and kappa is
like in that task, like, that's a new research framework, which is not framed in.
Yes. Yeah. Also, the research goal is a little bit different as well. So great. This is, and for these crispend of alpha, they have different interpretation on the value. So that keep in mind the different rubric or different ways would have a different like interpretation method. So different values means different as well. And yes. Data bias in representation, we would very super quickly cover this since it's we are running a little bit out of time. This paper is ACL 2023's best paper. So I think this is a very good one, especially regarding that. It is like highlighting the social biases behind the training data and the LM. So that although nowadays it's very quite common for investigating the bias of the model and their training data, but this paper, they actually did some like evaluation on whether the LM is generating bias or biased regarding some downstream task. There's also using some political and past tasks we might also mention before, related to one of the opinion preference generation. And then they evaluated that different model at the time actually have very different opinions. And maybe this figure is a little bit interesting, where they have actually two dimensions. One is about whether the model is more liberal or whether they are actually more conservative. This is one is whether the model is more left or whether this model is more right. And you can see that different models are lying in different places. So they are using these quantitative way to measure those subjective things, mapping these like two-dimensional way. So later on, these two paper are also some like other position paper arguing for diversity of the data set and who are actually counting as a high quality, etc. So these are also important topic in representing like a not biased data and yeah. So that is the last part of our talk. And I wanna ask your preference for our future, like the following lectures. Would you prefer me to share more broader or more like fewer papers, but with in-depth content so that you can have a better understanding of the specific research, how they are conducted, you know, going more into details, or do you prefer more about papers with overview so that you know a better overview of the task, but you might need your own effort to going deeper into what the specific paper are saying? Which one do you prefer? Let's do a voting. If you prefer fewer paper with in-depth content, please. if you want the other one. 1, 2, 3, 4, 5, 6.
Same.
5 versus 6. I would do my best to be a little bit focus more as we do majority vote. Okay, this is a good human annotation as well. So maybe a little more paper with overviews, but I would cover the depths as well. So assignment, I just created our research proposal, project proposal, so that it's due next Monday. And it's a New York time, 11:55. So that's take your time. And paper presentation, I already give the scores for you and you both. And thanks again for the presentation. And I will immediately grade this after that one. Here's the outline if you need. So feel free to check it. That's it. Thank you so much. Yay. Thank you.
就是第二个地方，就是那个